Welcome to my YouTube channel. I am Professor Amira Samir, a mathematics teacher. If you like my channel content, don't forget to press the like button and press subscribe to receive all the new lessons. Lesson number 3, writing expressions using the G.C.F. Let's solve the previous homework. Sylvia has 21 pencils and 14 erasers. She wants to put them in groups. What is the greatest number of groups that can be made so that each group has the same number of pencils and erasers? How many pencils will be in each group? How many erasers will be in each group? First, I have to find the factors of 21 and 14. Let's get the factors of 21. Factors of 21 equals 3 and 7. 3 times 7, 21. Factors of 14, 2 times 7. Now let's write this here. 21, 3 times 7, and 14, 2 times 7. The common factor between 21 and 14 is 7. So this is the G.C.F. And this is the greatest number of groups is 7. Now, let's know how many erasers in each group, how many pencils in each group. We will find this in next exercise. How can we use factors? Sammy is making packs of group of his friends going on a picnic. Each pack should have the same number of sandwiches and the same number of juice. What is the greatest number of snack packs that he can make with no any left over? That means we have to use all the number of sandwiches and the number of bottles. To solve this problem, I have to find the common factor between 60 and 90. Let's see how. Let's use the prime factorization. 60. How can I get 60? By multiply 2 by 30. 2 is a prime number. So let's take 20, 30. 30, we can get it by multiply 3 by 10. 3 is a prime. 10, I can get it by multiply 2 by 5. 2 is a prime, 5 is a prime. So we can get 50 by multiply 2 times 3 times 5, and the product is 60. How can we get 90? 90 is 9 times 10. 9, 3 times 3, 10, 2 times 5. Let's put the factors of 90 here. 2, 3, 5, and 3. G.C.F. is the common factors between 60 and 90. 2, 3, and 5. Then multiply 2 times 3, 6, 6 times 5 equals 30. So the greatest number of snack packs is 30. He can make 30 packs, but what the number of sandwiches in each bag or pack, what the number of bottle in each bag, we will see this next slide. The G.C.F., this is the number of bags. Okay, equal. How can I know the number of sandwiches and the number of bottles inside each bag? This is 2 plus 3 multiplied by 3. How can I do it? I can use the distributive property. How? 3 times 2 equals 60. How can I have 60 and 90? Okay, so we get the G.C.F., which is 30. Okay, how can I distribute this number or use the distributive property? 60 divided by 30 equals 2, plus 90 divided by 30 equals 3. So in each bag, I can find 2 sandwiches, or I can put 2 sandwiches and 3 bottles of juice. To check my answer, let's distribute again. 3 times 2, 30 times 2 equals 60. Plus 30 times 3 equals 90. This is the total number in the beginning we use it to solve the problem. Let's solve another example. Mona divides 32 bananas and 16 bottles of juice into equal groups so that each group contains the same number of both types. What is the largest number of groups that Mona can make? Use the distributive property. Okay, first let's get the factors of 32 and 16. 32, 4 times 8, 4, 2 times 2, 8, 2 times 4. Let's get the factors of 4, 2 times 2. So I can get 32 by multiply 2 times 2 times 2 times 2 times 2. 16, 2 times 8, 8, 2 times 4, 4, 2 times 2. I can get it by multiply 2 times 2 times 2. Let's put the numbers on each other's. 32 and 16, we have here 5 twos and 16 4 twos. So the GCF 2 times 2 times 2 times 2, 16. So this is the number of groups. Okay, now I want to know, I will put how many bananas in each group and how many bottles in each group. So I have 32, this is the number of bananas, and 16 bottles. And the GCF is 16. Let's put 16 out and see. If I divide 32 by 16 and put the answer here inside the two brackets, 32 divided by 16 equals 2. 16 divided by 16 equals 1. So the number of bananas inside each bag is 2, and the number of bottles inside each bag is 1. So the GCF is 16, and the greatest number of bananas is 2 inside each bag. The greatest numbers in bottles inside each bag is 1 bottle. Number 3, Muhammad wanted to share 24 pens and 36 notebooks in groups so that each group contains the same number of tools. What is the largest number of groups that can be made for each type of tools so that each group has the same number? We have to use all the tools. So we will use the distributive property. First, let's get the factor tree to find the factors of 24 and prime factors of 36. Prime factors of 24, 4 times 6, then 6, 2 times 3, and 4, 2 times 2. So the prime factors of 24, 2 times 2 times 2 times 3, 36, it's 4 times 9, and 4, 2 times 2, 9, 3 times 3. So the prime factors of 36 is 2 times 2 times 3 times 3. Now let's get the GCF. How can I find the GCF? Write 24, 2 times 2 times 2 times 3, 2 times 2 times 2 times 3. Then 36, 2 times 2 times 3 times 3. I have to write 2 under 2, 2, 2, 3, and 3 out. GCF is the common factors in each column. So 2 times 2, 4 times 3 is 12. This is the common, the greatest common factor, and this is the number of groups. Okay, let's see how many pens and how many notebooks. So 12. This is the GCF. Let's divide 24 by 12, it will be 2. 36 divided by 12, 3. So the greatest number of groups I can get it is 12 groups. And I can put 2 pens in each group and 3 notebooks in each group. Noura has 12 white flowers and 20 purple flowers. She wants to make bouquet with the same number of each color flower in each bouquet. What is the greatest number of bouquets she can make? And write expression to represent this solution. Okay, or situation. 12 and 20. How can I get 12? By multiply 3 by 4. How can I get 4? 2 times 2. 20, I can get it by multiply 4 times 5 and 4 2 times 2. Let's write the prime factors here. 12 equals 2 times 2 times 3. 12 equals 2 times 2 times by 20 equals 2 times 2 times 5. Okay, the GCF is 2 and 2 equals 4. So the GCF is 4. Okay, how can I write expression to represent this situation? 12 plus 20. Now, 12 plus 20, I get the GCF is 4. 12 divided by 4 equals 3. 20 divided by 4 equals 5. So the number of white flowers is 3 in each bouquet, and the number of purple flowers are 5 in each bouquet. A student has collected 12 grain bags at 8 packs of cheese in order of make donations boxes for the needy. Okay, I have some bags. In the first bag, I have 1, 2, 3, 4, 5, 6G and 4C. And here I have 6 and 4. In B, I have how many groups of this bag? 1, 2, 3, 4. In each bag, I have 3G and 2C. Number C, 1, 2, 3, 4, 5, 6, 7, 8 bags. In each bag, I have 2G and 1C. Okay, how can I solve this question? First, I have 12 from G and I have 8 from C. How? This is in each bag I have 12G. In these two bags, in each case, I have 12G and 8C. In this case also, if you count the number, the G, this will be 12 and 8C, and so on in C also, 12G and 8C. Okay, let's get the prime factors of 12, 3 times 4, and 4, 2 times 2. Prime factors of 8, 2 times 4, 4, 2 times 2. So the prime factors of 12, 3 times 2 times 2. Prime factors of 8, 2 times 2 times 2. GCF is 4. Now, so GCF is 4. Let's get how many number of G and how many number of C. Let's put 4 first, then brackets, and divide. 12 divided by 4 equals 3. 8 divided by 4 equals 2. So the correct case is number B. Why? I have 4 bags. Each bag contains 3 G's, 3G and 2C. Which expression represents the total number of items the student put into her boxes? Okay, 4 plus 3, which was of course from the previous slide, number C. Number B. We will have 4 groups. In each group, I can find 3 grains and 2 cheese, packs of cheese. Okay, so which answer is correct? It's number C. I have the GCF, or the number of bags is or packs is 4 and 3 from G and 2 from C. The same here. 3 times, if I distribute 4 times 3, I can put it here, plus 4 times 2, it's here. So the answer is C and B. Think about 4 times by 2 plus 3. May stands for, consider the number of food items you started with 8 and 12, and the number of boxes you made 4. How is 4 related to 8 and 12? So we have 12 grain bags and 8 packs of cheese, and 4 is the GCF of 12 and 8. 4 is the GCF of 12 and 8, and this is the greatest number of bags I can make it. Malak cooked 30 portions of Ali and 48 pieces of baklawa for her family. She wants to divide the desserts into plates so that each person gets the same number of the two desserts. Write a numerical expression representing the large can prepare. Okay, the large number of course, plates she can make. The largest number of plates is we have we have to get the GCF. How to get the GCF of 30 and 48? 30 we can get it by multiply 3 by 10. 10 2 times 5. 48. We have to get the prime factors of 48. 6 times 8. 6. 2 times 3. 8. 2 times 4. Then 4. 2 times 2. Let's write the prime factors of 30. 2 times 3 times 5. Prime factors of 48. 2 times 3 times 2 times 2 times 2. And get the GCF. GCF is 2 times 3 equals 2 times 3 equals 6. So this is the greatest number of plates Malak can prepare it. Okay, this is the largest number of plates, or greatest, G for greatest, greatest number of plates she can do it. Okay, so what the number of Ali and baklawa in each plate? Let's write down the number of plates, then divide. 30 divided by 6 equals 5. 48 divided by 6 equals 8. So she will put 6 from Ali and 8 from baklawa. So if I want to get the number of Ali and baklawa, we have to get first the GCF, then use the distributive property to find the number of Ali and baklawa. Ahmed wants to grow 23 jasmine plants and 16 lily plants in his garden. Ahmed wants to plant these plants in basins so that each basin contains the same number of two types of plants. Write the numerical expressions that represent the largest number of basins he can plant. The largest number of basins, let's get it, 24 and 16. How can I factorize 24? 4 times 6. Prime factors is 2 times 2 times 2 times 3. The prime factors of 16. 2 times 8 and 8, 2 times 4, 4, 2 times 2. So the prime factors of 24 are 2 times 2 times 2 times 3. 16, 2 times 2 times 2 times 2. The GCF is 2 times 2 times 2 equals 8. Now, how can I know the number of jasmine and lily in each basin? So we factorize 24 and 14 and 16. First, write the GCF out, which is 8. Then divide. 24 divided by 8 equals 3, plus 16 divided by 8 equals 2. So this is the number of plants. So he has to put 3 jasmine plants and 2 lily plants in each basin. Example number 8. There are 40 girls and 36 boys who want to participate in lab on teams. If each team must have the same number of girls and the same number of boys, what is the greatest number of teams that can participate, and how many girls in each team, how many boys in each team? Write an expression which represent the total number of participants. Okay. 40. I can get it by multiply 2 by 10 and 10 2 by 5. 36, 2 times 18, 18 3 times by 6. 6, 2 times 3. Now let's write the prime factors of 40. 2 times 2 times 5. Prime factors of 36. 2 times 2 times 3 times 3. The GCF is 2 times 2, which is 4. Now let's put 4 out. and see what the number of girls, what the number of boys. 40 divided by 4 equals 10. 36 divided by 4 equals 9. So I can make 4 teams. In each team, we will find 10 girls and 9 boys. How we can use the distributive property to complete this? Let's see together. If I don't have these two numbers and I have 8 times by, I don't know, 8 times 7 plus 8 times 5. First, you have to get the common number and put it outside the brackets. For example, here I have the common number is 8. So you can put it outside the brackets. Then write here the rest, 7 plus 5. Then distribute 7 times 8 equals 56. 8 times by 5 equals 35. Next one. 3 times 5 plus 3 times 9. The common is 3. Okay, so put it out. Then write the rest inside the brackets. 5 plus 9. Then distribute 3 times by 5 equals 15. 3 times 9 equals 27. Another one. The common is 7. We have to put it out. Then write the rest inside the two brackets. Then distribute 7 times 4, 28. 7 times 5, 56. And repeat here in number D. The common is 4. Put 4 out. Then write 3 plus 5 between the two brackets. Then distribute. 4 times 3 equals 12. 4 times 5 equals 20. So first we have to get the common and put it outside the two brackets. Then put the rest inside the brackets. Then distribute the numbers. In this case, he puts already the number outside the two brackets. So this is the common. That means I have to multiply 3 times by 10, then 10 times by 2. 3 times 10 equals 30. 2 times 10 equals 20. So the steps is get the common number and put it outside the two brackets. Then put the rest inside the two brackets, then distribute. The homework. Write the sum of two numbers using the distributive property. 25 plus 35. Number 2. Write the sum of two numbers using the distributive property. 16 plus 12. Number 3. Write the sum of two numbers using the distributive property. 45 plus 27. You will find the answer in next session, inshallah. See you next time. Bye.